Okay, today we are going for the session 4, and this course is RF system design. Course code is 21EC3016, and today we are going to discuss about RF behavior of passive components. So aim of the session is to familiarize the students with the concept of RF behavior and passive components. What are the objectives? So here we are demonstrating low and high frequency design component, describe the effect of a high frequency. And here we can think about the end of the session. The student will going to learn the behavior of passive components in the radio frequency domain influenced by their electrical properties and construction. Okay. Next is I am starting from RF micro circuit design, and here we are thinking about how we will design a circuit in RF, means radio frequency influence. So here these waves behave directly at different frequencies. So circuit design can be subdivided into two main categories. One is known as your RF circuit design consideration, second one is microwave circuit design consideration. So first we are coming to low RF circuit design consideration. In low RF circuit design, we have to go through 3-step design process. So in that process, the effect of wave propagation on the circuit operation is negligible. So for that we need to take care of this. So these 3 design processes are, first one is the length of circuit L is generally much smaller than the wavelength. Propagation delay time is approximately 0, means if you are receiving and sending the signal, that the time approximately it is going to 0. Practically we can't tell that it is equal to 0. Maxwell's equations simplify into all of the low frequency laws such as KBL, KCL, like that, and Ohm's law. So therefore at RF frequencies the delay time of propagation is approximately 0 when L is very less than lambda, and all elements in the circuit can be considered as a lumped element. So what is lambda? Lambda is the wavelength. Now if you are thinking about Ohm's law, this is our Ohm's law. So always any circuit, if you are thinking about low frequency, then it obeys the Ohm's law. So what is that Ohm's law? Everyone we knows. That means we have a resistor, and a resistor is there and battery is there. We are writing like V proportional to I, and we can write V equal to I into R. So this is known as your Ohm's law. But this law is only applicable for the low frequency application. So if you are coming to design process, then the design process we need to go for steps. So first step is the design process start with selecting a suitable device and performing a DC design to obtain a proper quality quotient point. Second one, the device will be characterized to obtain its SC, small signal parameters, based on the specific DC operating point selected earlier. Designing two matching circuits that transition this device to the outside world, the signal source at one end and the load at the other end. So always we will take like one signal source at the input. 1 minute. So signal source at the input, signal source we can write, and the load is at the output always. So in this step we can to think about stability, gain, and noise. Okay. So this is we are going for 3 considerations. One is stability consideration, gain consideration, and noise consideration. So if we think about stability consideration, we need to go for device characterization. For that, so first we will think about DC design consideration, then we will go for the Q point, and after that we are coming to this consideration. When we characterize, we need to go to characterize device characterization, that means characterize the device. Step 3 is a circuit matching concept. This matching concept is most important. It is already we discussed in the session 1 and 2. Active circuit, also we need to take the active circuits, and that active circuit means if it is a active circuit and the second one is also a active circuit, then we need to give a matching network to make it the maximum power, to make the maximum power to be transferred from one active circuit to second active circuit. So now if we are coming to high RF and microwave circuit, then we can think that as per the distribution, so everything means that if you are telling about the microwave circuit, one or more lumped elements but should contain at least one distributed element. So if a circuit contains at least one distributed element, then we can tell it is a microwave circuit, RF microwave circuit. So if we are thinking about a element, then that distributive element should spread out over an electrical significant length or area of the circuit. Let us say that a distributor, if you are thinking of telling about an inductor, it is lumped. If you are thinking about a transmission line, in that the if inductor is present, that is known as your distributed one. So distributed inductor is an element whose inductance is spread out along the entire length of a conductor. Okay. Now if you are thinking about capacitor, then same thing we can tell. Capacitor is an element whose capacitance is spread out along the entire length. I am telling about distributed of a wire and not concentrated within a capacitor. So for this other distributed circuit, we need to know the following facts. The fact one is the wave propagation concept as set forth by Maxwell's equation fully apply. So here we are applying the Maxwell's equation. Second one is the circuit has a significant electrical length, that is its physical length is comparable to the wavelength of these signals propagating in the circuit. The time delay due to signal propagation can no longer be neglected. So time delay we can't neglect. If you are thinking about the RF and the microwave circuits, instead of DC or low AC signals, then we will feel four effects. So these four effects coming into existence. One is presence of stray capacitance, presence of stray inductance, skin effect and radiation. So if you are thinking about stray, so what is that stray capacitance? The capacitance that exists between conductor of the circuit. That means if it is a conductor, in between I am placing a capacitor, then this conductor and capacitor we are getting some more capacitance due to the RF frequency. Second one, conductors are component and the ground, and also you can think about the ground this side, that is also we can, and between the components. So if a capacitor is here and second capacitor is here, in between also there is a stray capacitance will present. If we are thinking about presence of stray inductance, so the inductance of the conductor that connect component, it depends upon the inductance of the conductors that connect components, the parasitic inductance of the component themselves. So a resistor can be written like this. If you are thinking about a stray inductance, that means we are thinking about the high frequency. So you can think that if a conductor is there, if we are thinking about high frequency, it behaves like an inductor. So if you are thinking about skin effect, what is that skin effect? We can think about this structure. Here if a signal is coming, that means it is a conductor, then it is going deeply, it is penetrating the conductor and return back. So how much it is penetrating, that is known as your skin depth. We can calculate the skin depth value is equal to 1 by pi f sigma mu. So this is the skin depth. So what is that skin depth definition? The definition is depth of penetration of skin depth or density or signal amplitude is 1 by E or 36.8% of its surface amplitude. If it is 36.8% penetrating, then we can think that it is known as your skin effect. So you can see here also we have a skin effect if a signal is coming like this, and here in boundary also we are getting the skin effect. So here the parameters are del is the critical depth, f is the frequency in hertz, mu permeability in hertz, and sigma is the conductivity in moles per meter. So these things if you know, then we can calculate the skin effect. Then last effect is the radiation. So due to this Keene effect, due to this coupling, so we are getting the radiation. Now mainly this is caused by the leakage or escape of signals into the air. Okay. So radiation factor, so that means we are thinking about radiation factor, it depends upon coupling between element of the circuit, coupling between the circuit and its environment, coupling from the environment to the circuit. So we can tell that electromagnetic interference, also called radio frequency interference or RF noise, and considered to be negligible in most low frequency AC circuits and absent in DC circuits. Sorry for interruption. So now these are most about your effects of radio frequency to the passive components. So these are some means questions I am asking. The RF behavior of passive component refer to its characteristic at which frequency, and the parasitic capacitance of an inductor is primarily caused by what? So these two questions is open for you. Also we can discuss so many questions in our classwork. These are the terminal questions. You can see one by one and you can to prepare for the terminal ones. Now reference books, I have taken these reference books and the site of web links, and this is the thank you to all those who are listening my audio and those who are watching my video. So this is I am Dr. Arjun Muduli. Thank you on behalf of KL University.